Rotational dynamics. In this section, we're trying to explain the rotational motion using the torques. So we need to define the torque. The torque is defined as force times the lever arm. Lever arm is the shortest distance from the rotational axis to the line of the force. So in this diagram, it's capital L times sine theta. So the torque is force times L times sine theta. The units of torque are Newton meters. And there is also a convention about the sign. If the force makes a clockwise rotation, we consider that as a negative torque. If the force makes a counterclockwise rotation, we consider that as a positive torque. And this equation gives us only the magnitude of the torque. It doesn't give us the direction of the torque. So these are some examples. In the first example, we have a 3-meter rod and force is 12 newtons and it makes a 30-degree angle. In the second example, it's 3 meters but the angle is 90 degrees. The same, the difference in each example is the angle. The angle is different. So let's go over each one and find out the torque in each case. We need to find the lever arm in each situation. For this situation, lever arm is 3 sine 30. So that's 1.5. So the torque is 12 times 1.5. That's 80 Newton meters. This is a clockwise rotation. This force makes a clockwise rotation. So it's a negative torque. So it's negative 80 Newton meters. In the second one, lever arm is same as the length of the rod because it's a 90-degree angle. So L equals to 3 meters. So the torque is 12 times 3. That's 6 Newton meters. Considering the direction, it's a negative torque, so negative 36 Newton meters. Now here, the angle between rod and the force is 0. So that means the lever arm is also 0 because the distance to the line of force from the rotational axis is 0. Okay, so torque becomes 0. In the last example, this is a 230-degree angle. And to find the shortest distance, we need to extend this line and then we can find the shortest distance to that line from the rotational axis. To find this distance, we need to find the angle between this extended line and the rod. Since the total angle is 230, this angle must be 230 minus 180, which is 50 degrees. So L equals to 3 sine 50. That's 2.3 meters. So the torque is 12 times 2.3. That's 27.6 Newton meters.